Okay, Algebra 2, this is section 2.6, example 6, absolute value functions. This one might be a little bit longer of a video because I'm going to show you some calculator stuff with this. So I'm going to plug in some values for my x here. Remember that absolute value marks, when we were doing solving equations that were absolute value equations, we had to make two equations. So now that we're graphing absolute value functions, we're probably going to end up with two of something. So let's take a peek and see what we get. I'm just going to start out real easy. I'm going to go 0. If I put 0 minus 3, that would be negative 3. So negative 3 absolute value would be positive 3. If I put in a 1 here, 1 minus 3 would be negative 2. Absolute value of negative 2 is positive 2. And I'm still in 2 for x. 2 minus 3 is negative 1. Absolute value of negative 1 is positive 1. Let's go to 3. 3 minus 3 is 0. Absolute value of 0 is still 0. Then I can go to 4. 4 minus 3. 4 minus 3 is 1. Absolute value of positive 1 is positive 1. 5. 5 minus 3 is 2. Absolute value of 2 is 2. And 6. 6 minus 3 is 3. Absolute value of 3 is 3. Then I'm going to grab my marker, and I'm going to graph these points. So 0, 3. 0, 1, 2, 3. Which should make sense. Our y-intercept is 3, and if this were y equals x minus 3, you would guess that the y-intercept would be a negative 3, but we're absolute valuing it, so it happens to become a positive 3. 1 is 2, 2 is 1, 0 is 3, 4 is 1, 5 is 2, and 6 is 3. Notice we're getting a v. At 3, right here, we change directions because we can't have our f of x be negative because of our absolute value marks. Since our absolute value marks are there, we can't go negative with our y, so when we would hit the y, or the x-axis, we would have to bounce and go back to positive again. So let's put this in, let's graph here, and we're going to put our lines in there and connect them up. And there's what your actual function looks like. It is a v. And again, normally it would have continued on, and it would have gone through the negative 3 right here. But since it's an absolute value, we are going to change directions and make it go back positive. And so instead of a negative 3, it is going through at the positive 3 for our y-intercept here. Okay, so let's look at that a little bit more closely. Say I want to take these equations and I want to graph them on a graphing calculator. And I want to see what this part right here is doing to an absolute value. So let me grab a graphing calculator, and I just so happen to have found an app online. Can I make it smaller? Probably not. Yep, I can. Okay. So let's make this a little bit smaller and graph these. And you can graph on your regular calculator the same way too. You should have a function. It's the absolute value function. And then I can just put in my x. And I can graph that thing and see what that looks like. Okay, so our y-intercept would be 0, so we are changing directions at 0. Let's put in the next one. Absolute value, and this one I want to do of x. But then I want to add 1 at the end of it, outside the absolute values. Now let me graph that one. And you're going to see that that one moved it up 1. So when it's adding 1 on the outside the absolute value, it went up 1. Let's try another one. Grab the absolute value, and let's put our x in there. And now let's add 2. Now, if adding 1 went up 1, adding 2, we would guess, would move it up 2. Okay? So this adding 1 is going to move it up. Let's do an absolute value. I'm going to stick with plus 4 because we're assuming that that's going to move it up 4. Let's double check that subtracting 2, our guess would be adding 1 and adding 2 moved it up 1 and up 2. So subtracting 2, if our guess is good here, should move it down 2. Let's take a good look at this. And yes, in fact, our yellow is down 2. So when the number is on the outside the absolute value, it is moving it, move it up and down. Okay. Let's look at another example. What happens when we are multiplying? When we're multiplying here, what's that going to do? Let me grab my graphing calculator and let's clear these out of here. Get that one out of there, and that one out of there, and that one out of there, and regraph. So we're starting with our y equals absolute value of x. Now we're going to try our next one. So we're going to write 2 times the absolute value of x. And let's graph that and see what that does. Okay, and in y equals mx plus b, that would be our m, so that should be our slope. And notice we're going to have a positive part to our slope, and we're going to have a negative part to our slope because we're doing the absolute value. So let's take that next one in here. If 2 made it steeper, let's see what the absolute value of 3 times the absolute value of x does. And let's graph that. And it does make it steeper still. Now this is an absolute value slope of 3, and this is a negative 3. What happens if that's a negative 2 on the outside? Let's just go back and make this one a negative 2. Get rid of that one altogether. Okay, so I'm going to get rid of my blue one. I'm going to change that from a positive 2 to a negative 2 and see what that's doing. Okay, so that one flipped it over, flipped it and reflected it right across my x-axis there. Okay, so the negative 2, you now have your negative slope on one side and your positive slope on the opposite side, and it reflected it across your x-axis. Let's make a rule here for this. So our number in front is the slope, but it is negative and positive. And if the slope is negative, it reflects across the x. So I'm going to go back to my graphing calculator, and I'm going to add one more onto here. What if this were a 1/2? Let's make sure that really is our slope. So a 1/2 absolute value of x ideally should be flatter, less steep. I see to that. So is my yellow less steep? And it is. It actually is going up 1 and over 2, and it's going up 1 and back 2. So it's a positive and a negative 1/2. So this rule that we just created does hold true. The number in front is in fact the slope. It has a negative and a positive part to it because we're absolute valuing. We set up 2. And if the slope is negative, we are reflecting across the y-axis. Let's verify that one more time. We'll change this to a negative 1/2. And that one should be flipped across, and it is. So the yellow and the blue are now reflections of each other. Okay, so another example I want to look at is what happens when you're adding and subtracting, and it's on the inside of the absolute values. Let's grab our calculator again and clear off our graphs. But we can leave that first one because that's our constant. We graph that and just put our first one back on there. So let's see, if we've got the absolute value and we want x plus 1 inside. So if it's outside, it moved it, where were we? Okay, when it was outside, we moved it up and down. So now that we are inside, let's see what it's going to do. Okay, so when it added 1, it actually moved it back. Let's try another one. So we've got the absolute value, and we want to do x plus 2. So if adding 1 went back 1, adding 2, we would guess would move us back 2. Okay. So then if I added 4, we would guess that it would move us back 4. Okay. Well, what happens if I subtract 2? Okay, well, subtracting 2, move this forward 2. So it's going to do the opposite of whatever's there. So if this were, change this one to subtracting 2, and let's change this one to subtracting 1, and we'll make this one subtracting 4. And now they should all be on the positive side because I'm subtracting. So on the inside, it's going to move it the opposite direction, and it's moving it forward and back. So our rule here would be the number on the inside moves us forward and back in the opposite direction. Okay, so now we have our rules. We have numbers on the outside are moving us up and down in the same direction. The number we're multiplying by is, in fact, our slope. We've got to take the positive and the negative part to it. And the number on the inside is moving us forward and back, but in the opposite direction. So let's take a guess at where this graph is going to take us, and then we'll plot some points, see if we're right. So we know our slope is going to be 2. We know we have a positive 2 on the inside. Positive 2 on the inside means that we are going in the opposite direction, forward and back. So that means we're going to go back 2. And the number on the outside said move it up or down 1. Okay? So we're going to go down 1 and back 2. So down 1 and back 2. And let's put a point there. Down 1 and back 2. That's where we think we're going to guess the bottom of our vertex is. And then our slope is going to be a positive 2. That means up 2, forward 1, up 2, forward 1, up 2, forward 1. And we have the negative part to that, so it's up 2, back 1, up 2, back 1, and up 2, back 1. So now let's see what we get when we take our x and g of x and actually plug in points. So we are guessing, let's start with negative 2, because that's where we are here, negative 2. We are guessing that negative 2 should end up being a negative 1. So if I put a negative 2 in here, that's negative 2 plus 2 is 0. 0 times 2 is 0, and that is, in fact, a negative 1. Okay, so that one worked. Okay, so let's try another one at negative 1. Negative 1, so it's negative 1 plus 2, that's a 1. Okay, so 1 times 2, that's 2, and 2 minus 1 is 1. So we think that negative 1 should be 1. Negative 1, 1, that's what we get. So now we're at 0. Let's try 0. And let me get rid of that. Okay. So if I put a 0 right there, 0 plus 2 is 2. 2 times 2 is 4. And 4 minus 1 would be 3. And it's 0, am I up at 3? Okay, so that part works, so that's looking pretty good. Let's try the negative 3 and see what that does for us. So negative 3. Negative 3 plus 2 is a negative 1, and negative 1 absolute value would make that a positive 1. Positive 1 times 2 is 2, and 2 minus 1 is 1. So at negative 3, I should be at 1. Okay, so let's try negative 4. Negative 4. Let's put negative 4 right there. Negative 4 plus 2 is a negative 2. Absolute value is a positive 2. Times the 2 is going to be 4 minus 1, and 4 minus 1 should be 3. And at negative 4, am I at 3? I am. So it looks like I did it perfectly right. And so there is my line, and I want a solid line, not a dotted line. And my absolute value would be a v, and I would be back 2, down 1, with a slope of 2. Let me make notes of that again. So I went back 2, I went down 1, and m was 2 and negative 2. Right?